Hi, folks. We got a really good question last night about how to factor the derivatives fully. And in order to look at that, I'm going to take up part of the derivative solution for number 7 on, I believe, the day 3 homework. But in order to kind of get to that point, I want to just sort of review some basic common factoring and how we can extend that. So if I gave you guys a question like, a to the exponent 7 b cubed plus 4a squared b to the exponent 5. Say you were helping your sibling in grade 9 or 10 learn how to common factor. What would you probably tell them about how to choose how many a's and b's get factored out? I think odds are that you guys would tell a younger sibling the rule is that you're going to look for the smallest number of a's. So this first term has a to the 7 and the next term has a squared. So you would say, oh look, you can only take out 2 a's. And anybody I taught in grade 10 hopefully remembers those rules. And then you would look at the b's and you say, oh, here has b cubed and here has b to the 5th. So we're going to take out the smallest number of b's. And I know that this is easy for you guys, but just to kind of take a look at the process here. So you would common factor out a squared b cubed, and then to create the rest of the bracket, you'd say how many a's do I need to add on to a squared, not add on, but multiply. How many numbers in the exponent do I need to add on to get to a to the 7? So you'd say, oh, I have to add 5 a's. So a squared times a to the 5th is a to the 7th. And those exponents add up to the original exponent. And likewise, we would say, oh, here I've and no b's. Obviously, you factored out all of the b's. And then you'd say, I have factored out my a squareds. How many b's do I have to add to get to b to the 5th? I've got b cubed, so b squared. So again, looking really at these exponents, that the exponent that you've factored out and the exponent that's remaining in the bracket would add up to the original exponent each time. So that's simple grade 9 and 10 common factoring. To take that a little bit further, what if you had x to the negative 3, y to the 4 plus x squared y to the negative 1. If we wanted to common factor this one, again, we're going to follow that same strategy of choose the smallest number. And now we're thinking that the smallest has to include that negative numbers are smaller than positive numbers. So I'm going to look at the number of x's that I have in each term. And if I have x to the negative 3 and x squared, that negative 3 is a smaller number than the x squared. So that's my smallest exponent of x. And then looking at the y's, we have y to the exponent 4 and y to the negative 1. We want to factor out the smallest exponent of x. And this works exactly the same all of a sudden when the exponents are integers. So my common factor here would be x to the negative 3, y to the negative 1. And then when I'm making my bracket, I have to think, how many x's do I need to add on, or how many y's do I need to add on to get to where I originally was? So here I've factored out all of the x's. I've got x to the negative 3 factored out. But here I need y to some exponent, and I've made my brackets way too big, y to some exponent that if I multiply it by y to the negative 1, I get y to the 4th. So negative 1 plus something equals 4. So I know I'm going to need 5 so that I can add these exponents up and get back to the original exponent. And then likewise with the x's, I have x to the negative 3 here, and I need to put some more x's so that when I multiply those together, I'll get x squared. So I'm going to add negative 3 plus some exponent on x over here that would give me a 2. So negative 3 plus 5 equals 2. So you have to kind of imagine what would happen if you distributed this back out. You want, just like in the smaller example here, we want to think, oh, 2 plus 5 gives me that exponent of 7. Same thing with integers. Okay. The next example I want to look at is if we have rational exponents. So fractions, fractions with negative signs. So for instance, if we had, let's say, a to the negative 3 over 2, b to the 1/2 plus a to the 1/2 b to the negative 1 over 2. And normally these do, when we're using the derivative rules and getting these rational exponents, they normally do work out to kind of typically similar denominators like this. So in this case, I want to look for each variable term and see which is the smallest exponent. So for my a's, I have a negative 3 over 2 exponent and a 1/2 exponent. So negative 3 over 2, that's the smaller one. And then for my b's, I have positive 1/2 and negative 1/2, and the negative 1/2, that's a smaller exponent. So here I would common factor out those two smallest exponents. So I would say this is a to the negative 3 over 2, b to the negative 1/2. And then when I'm building my bracket back up, I think, what do I have to multiply by to make the original expression? So a to the negative 3 over 2, it's already, the whole thing's factored out. But I have to think, how many b's do I have to multiply here to get b to the positive 1/2? So I have to think, what exponent here would add with negative 1/2 to give me positive 1/2? So kind of maybe write it down here. So I'm going to have negative 1/2 plus something equals 1/2. That's what I'm thinking about for the exponent for my b. That's kind of my like thought process to get that. And most of you guys will be doing this just in your head, which is fine. And we know that negative 1/2 plus 1 equals positive 1/2. So that would be just b to the 1, or just b. And then for the second term here, I know that I've factored out the full b to the negative 1/2. So I need to figure out how many a's I'm multiplying by. And now I'm thinking I've got negative 3 over 2, if I'm adding my exponents, plus something equals, and it has to equal positive 1/2. So here, this is negative 3 over 2 plus something is my exponent on my a. So that's where I'm kind of, that's my thought bubble of how I get that exponent. So here, negative 3 over 2 plus 2 equals 1/2, because that's negative 1/2, and we want to add something to get to positive 1/2. So that would be an a squared. When you do this, I'm just going to kind of skip down past my little thought bubbles. I do want you to write this with positive exponents. So this would be b plus a squared over, and then it would be a to the positive 3 over 2, b to the positive 1/2. So we want to get those terms down to the denominator with positive exponents.